and welcome back to our agent-based modeling tutorial using Julia and Agents.jl. In this tutorial, we'll extend our model and we'll also do some housekeeping, so to say. Because one thing that is critical in keeping your model clean is by making sure that you have things organized in a way. And we've already experienced this a little bit when we went down here for the videos and for the plotting, and then we had to go back, and we had lots of in-file navigation. And a good way to make sure that you separate your model from your analysis and from your viewing is by putting it in multiple files. And a sensible structure can be to have a model.jl, and inside of the model.jl we put everything that is model related. And this includes the using agents, the agent. Let's remove this unnecessary comment here. The initialization function, that is something that we need. Probably also the behavior, and all of this we just take, cut it out and put it into our model.jl. And if we now need this, we can basically just go include and do model.jl. And now we have this very short function where we can call our video or our plotting. And in this case, it might even make sense to do something else, and that is do video.jl. And inside of the video.jl, we just copy all of this and we put it here, and we remove the figure plotting and remove the chiromakey thing. And so now we have this small little file. If I run it, this will generate the video of our current model and just do 200 time steps. And it's a very small file footprint, so to say. And if this works, we have something to go back to, and we can use this as a testing ground to see if our model creates what we want it to create. But there's another thing that we can do with agent-based models in Agents.jl, and that is interactive evaluation. And to do this, we create a new file, and let's call this interactive.jl. And at first we just copy everything from let's copy everything from the video.jl and put it in here. And one thing that we will do is we will, instead of doing our model MP4, we will do the following. Did this load already? Yes, it did. We have a new model, and all of this ran. We see this because we have the this little check mark here. But we now want to do an interactive visualization of this, and for that we get our model initialized. We get our person coloring. We have, maybe it might make sense to have a file. Let's do that. New text file, and we'll save it as rendering.jl. We could also plotting. Let's do plotting. Plotting.jl. And everything that's related to plotting, especially this, because there might be more in the future, I will put into the plotting.jl, and I will remove it from the video.jl as well. And in the main.jl, I will also remove it, and I will add this here as include plotting.jl. Now, this doesn't make a lot of sense at the moment, because obviously we removed one line and added a line, but as soon as we add more, all these files, so if we go from red to, let's say, green, now all these will have the same visualization function because we have this unified plotting thing in here. And the only thing that's different between video and, main is kind of only like our testing ground now. The I think the video stuff I can remove here because we don't need that. And maybe we can save the main.jl also as save as figure.jl. So this is just to create a figure. But we wanted to do the interactive thing. So for the interactive thing, we do this, and this works. The model loading works, the include works, the model initialization works, GLMakey works as well. But the thing what we now want to do is we want to, instead of do agent BM video, let's kind of remove this and do ABM exploration. That already sounds very interesting. So the idea is that we explore a model, and for that we need an agent step function. The agent step function is defined in the model.jl, so we have that. And that alone is not sufficient. We also need to add the visualization functions such as agent color, and for that we would use the person color function. The agent marker, we would have the rectangle. The agent size would be, I think we need a, no, we need it, oh, it's already there. Agent step is already a keyword argument. Agent size, let's go 25 again. Let's see if that works already. And for this, it's critically important that we don't use the plot pane, because the plot pane will make that this does not work. We have to have this as a separate output. And the output is generated here in an external Julia window. I think, where is it? No, it's not. Did it not work? Oh, no, it's not. We have to get to it. So this again has a figures. Let's see that. What is the outcome? ABM exploration. What does it returns? Figure and AB mobs. AB observable. ABM observable. It's not mobs. It's ABM observable. Okay, good to know. And we get a scene, and this first thing is what we're interesting, the figures. And once we run that, it should return a figure, and it should give us, there it is. And now you might have a little problem because this is kind of not so easy to read, but this is an interactive version of our model. And we can step through this model, and we can already see that choosing green was a bad idea. So let's close this again, go back into plotting and say, no, red is a lot easier to determine. So let's start all over again and open our, yeah, that's what we want. So this is our interactive version, and we can step through the model. We can not only step through the model, we can go on run, and this model will now continuously run. And we can, by moving this slider lower, we can increase the speed, and now you see that it's running really, really fast. And we can stop the model. So this is, oh wait, run model, this is where you click to stop the model. This is one way of how you can interactively explore this, but this isn't really interactive because it doesn't allow you to change anything. It just allows you to run and stop the model. And the reason why we're using this is sometimes Makey crashes, so I have to manually kill it. Program is not reacting. Quit immediately. Whoops, I clicked on something. I hope that didn't cause any trouble. It didn't, I hope. Okay, so this isn't really helpful. One thing that we want to do is we want to have a look at what is the outcome of some of these things. So for that, we have a variable called agent data, a data. That's a variable that we can put in here. We just say a data, that tells us what data to collect. And in here, we can now have a tuple that tells us what feature of the agent, for example, health, we want to summarize. For example, this creates a summary by calling the sum function on all of our agents. So if we start this, it has to restart Julia, obviously, because we killed it. And the figures, they are running, and as soon as they are there, we now get an additional output in the, is it running already? No, it's not. Takes a moment. There it is. And is it doing something? I don't know. It is doing something. It's creating the scene and it's rendering the scene. There it is. And now I have this additional window, and this is the new Makey window. And what this does is, by zooming in, you see that if I now step the model, it will count 1 agent was sick, 5 agents are sick. And in the next model, 10. And what we see here is exponential growth and decay. And if we run this model, and if we increase the speed of the model, we can see that the function that we've created an equilibrium, so to say. Our model is now pulsating and increasing numbers, decreasing numbers, increasing numbers, decreasing numbers. And this is a semi-stable state of our model, which we've created by using the rules that we've been using. And we can reset the model and see if the same thing happens again. And since we're using a seed, this will obviously create the exact same outcome. It doesn't show you anything different. And we can recreate this as many times as we like, and we can clear the data. And clearing the data without resetting the model obviously starts in the middle of a run, so that doesn't make sense. And we can make it even faster. So this is how fast we can interactively explore the model, and over time you will see that this accumulates data, quite a lot of data actually, how many agents are ill, and 400 is the total amount of agents available, and in this model we have probably about 350 always ill in this setting. Let's close this again. That's kind of interesting, but it's also not very instructive. We cannot do anything about it. So it makes sense that we not only visualize results, it makes sense that we also manipulate parameters of the model. And this is achieved by creating a dictionary. And in this case, it's a dictionary that refers to the signature of the model initialization function. And let me quickly click away this exporting function. I'm exporting other videos and it's telling me that it's been successful, so thank you for that. In the model we have the initialize function, right? Where is it? Here. And this has parameters, these, and we can copy these and go into the interactive mode and put them in here. And now these are symbols, and these symbols, now, because it's a dictionary, they have to have an arrow in here. And we don't have to have all of them in here. So for example, we could say, okay, we don't want to change the grid dimensions. Let's keep them the same. Maybe we also don't want to change the total agents. Let's keep them the same. And the seed, I don't know, maybe that's also, it makes sense to have the same seed over and over again. But the idea now is that the parameters that we want to change, we could have a collection of them instead of a single value. So we could take all the values from 0.0 to 1.0, but do it in a step of 0.0. So what this does, if I do this, whoops, if I execute only the highlighted code here, it gives me an array that starts at 0.0 and it goes all the way up to 1. So the susceptibility increases from 0% to 1% to 100%. It doesn't really make sense to have 0 because we know that nothing is going to happen. So let's start at 0.1. And the illness duration, how about we do 5 to 15? So this could be a params object. And what this does is if we supply this params object to our Makey function, to our exploration function, we can now, as soon as it's ready, open our Julia window. And if I increase the size of it, you can now, it's really hard to see. I think I'll keep it smaller and then zoom in editing, is we have an illness duration, which we can change. Let's reset the model, by the way, and run the model. And let's move it a little bit faster. So right now we have an illness duration of 7 days and a susceptibility of 0.03. If we reduce the susceptibility of 0.1, what we see is if only 1 out of 10 events is a infectious event, we see that we arrive at a much lower equilibrium, so to say. And if we decrease the illness duration, we can see that it goes even lower, but we might even also get more variability in here as well. And we can now systematically test different options from 5 days illness to 0.1 illness, and we can increase the illness duration. And then it only takes a moment, and we see that we get a similar course of the disease as when we have the illness duration lower with a higher susceptibility. If we increase the susceptibility now to 0.9, I think we will arrive in a state where almost everyone is ill, but obviously not everyone, because every 15 steps every agent is not ill 1 of 15 steps. And if we clear the data, we will see that it traverses between these 15 steps, and most of the time around 360 or 370 people are ill. And this allows us to test the impact of these parameters on the model outcome, on the stability of this model. And that is how interactively exploring allows us to test different models. If the simulation for some reason is too slow, you can also skip steps, like if you want to look at long-term outcomes, because the simulation is a lot faster than drawing the outcome. So you can now only print a data point every 50 steps of the simulation, and now we're kind of like already 10,000, 20,000 steps in the simulation, 30,000 steps. And we can really create long-running simulations with this without even having to see all the individual data points. And that is how we can create interactive visualizations. We can add more features to that. There is ways of giving the axes labels, but for the sake of brevity, we'll keep it at this. We just change the parameters that are important for the model. One thing that is also interesting to know is if you want to have different seeds, it might make sense to have maybe something like 1 to 10, so you can try out 10 different seeds. If they have very dramatic impacts, I don't think they will do, so let's test it out quickly. Is it done? It is done. And so now the seed is, the parameters, by the way, are arranged alphabetically. So if you want the name to be at the bottom of the list, then let's make this a little bit bigger. You should give it another name. So let's run the model, increase the speed, and we see this is the initial version. So if we now move the seed to 4 and reset the model, it fails for some reason because the render loop, but now it's back on track. I'm not really sure what happened. Maybe I was reset the model. Maybe it's waiting for data that it's not getting. It's actually working in the background. I'm not sure what's happening. But what we see is the different seeds do not really create systematically different behavior. I mean, we do see this error, which I'm not sure what's going on there, but it's probably a problem of this interactive visualization. And it's also getting slower. So let's make this faster and see if anything here happens. If I put what happens if I change the seed, it has to create a completely new model. We have to, I think, stop the model, update the parameters, and then run the model again. Oh, and we have to reset the model, obviously, because if there's a new seed, the seed is something you cannot change afterwards. Yeah, that is probably not the smartest thing to do. So changing seeds is probably not the best idea in your interactive environment. There is a non-interactive evaluation that you can do to determine the impact of different random seeds. And this is what we then would call what we now did is we tested the parameters, but what we can also do is systematically scan the parameters in the model. And in this case, we would have a function called a parameter scan, and we will just copy this file. Let's save it, file, save as, and we'll call this paramscan.jl. And the parameter scan basically works the same. We initialize everything. We don't really need the plotting thing. We could comment this out. We don't even need to initialize the model because we don't start from a basic model, but we start from, oh, maybe the ABM exploration didn't need an agent step, but an initialize function. A labels, does it, can we see that? Is there ABM exploration gets a model? No, it changes. It probably ignored our agent step function. I'm not sure. Where were we? We wanted to do parameter scanning here. So instead of ABM exploration, we do scan parameters. No, wait. No, we do param scan. So we param scan the model, and we don't need a model. Whoops, what did I do now? We don't need an agent step. We don't need a model because the model is generated for us using the initialize function. So we tell it the function that it's using to initialize the model. And we need, so what does it need? It doesn't need the color because it's not plotting anything, but it does need the data that we want to analyze. It does need parameters, but these are now not optional, these are important. So let's put them here in the front. Params, I think that's also param scans. How does it work? It requires first parameters, then the initialize function, then keyword arguments. Parameters, initialize, keyword arguments. And it probably doesn't return figures, but it returns an agent data frame and a model data frame. And we'll have a look at the agent data frame. So because we're looking at agent data, we could also, if the model had changing parameters, we could also have a look at those, but we're not doing that here. So we have the params, we have the A data, and that's, I mean, that should probably already work. We could do the seed as well in this case, and we just do 1 to 5. So we do 5 iterations of the same model, and let's see what happens if I just kill the Julia console and do a new one. And let's activate our project and the model. Let's get the health function. The params function is set. We don't even need glmake anymore. So we can, after this, directly do param scan. And it produces an error. And the error is what? No method matching run single. Dict symbol with 3 entries. Illness duration, seed susceptibility. Wait, what are the params? Parameters is a dictionary with key type symbol. Each entry of the dictionary maps a parameter key to the parameter. Oh, okay. We have to use all the parameters of the initialize function. So let's copy them. And that's the difference. And that's why I remembered that we need to copy them. So we need to have all of these parameters in there. And I'll put them all in, and I'll turn that into a legal map, a legal dictionary, I'm sorry. And let's remove the ones that are duplicate. This is duplicate, and the illness duration is duplicate. So what we typically, the order that we would have is grid dimensions, total agents, susceptibility, illness duration, and the seed. And that should work now, if I'm not mistaken. No, it doesn't. No method matching seed, Soshiro, unit range. Oh, this is now a range, and I think ranges do not work for the param scan. You have to collect them, and maybe you have to need to collect the others as well, because it doesn't know that it should iterate over them. But if we make a, if we collect these, then we do not get an error, but we get multiple things. We get a data frame and we get an MDF. The MDF is a 550 by 3 data frame, and the result of that data frame is it takes the illness duration, the seed and the susceptibility. So these were 550 simulations that it ran with these parameters. This is the model data frame. But the more interesting thing for us is the agent data frame. And there's a fly around here annoying me. And what we now see is, let me make this a little bit bigger and call this ADF again, because then we'll use this. We now see that it has 1,100, or it has 2,175 rows in this ADF. And for every step that it ran, it has the health, it has the illness duration, the seed, and the susceptibility. And this is the sum of health. So how many people were ill in this model? And interestingly, it only does steps 0 and 1 because we didn't give it an amount of steps to run. And that's the next thing that you should always do, is give it, I think, n equals maybe 30. It will run the parameter scan, and now it has 17,000 parameters analyzed for us. And if we run it again, we should now see that, oh, there it is. It does the steps until the 30th step, and it does it for all the individual illness durations, the individual seeds, the susceptibility, and so on. And if we want to analyze the data in R, Python, or whatever, it makes sense to keep them in a CSV file. So we would add the CSV package. And adding a package takes only a short moment, as we've seen. If it takes a while, I'll add some music. No, it's there. So what we can now do is, using CSV, we can then do write. And we would say our data.csv, and we would write the agent data file. Agent data frame. Let's see. No method matching write data frames. Do we have to do csv.write? Yes, that's what it does. Because there's multiple write functions and we want to use the csv.write. And we can now see our data.csv. This is a CSV file containing all the 17,000 something 52 steps of our model, 17,051 that have been conducted using this parameter scan. And this allows us to systematically explore the space of all the parameters and keeping all the data that we want in a CSV file. If we don't want to have if we don't want to have a sum of health, but we only want to see each individual's health, if we do not use tuples, but if we use a single array, and we could also add other values like health duration and see, let's do that. Illness duration, that's what it's called, illness duration. Now we collect two parameters, and if we do this, column illness is already present. Oh, that's an interesting thing. Because the agent has a field called illness duration and the model has a field called illness duration, this is a problem. So we should probably make sure that we name these differently, because then they cannot be part of the model. Let's do it model illness duration here. So whenever the parameter requires model illness duration, we will change this here, we will change this here, and we will change this in the model illness. Well, that's it now. It's kind of duplicate model.model illness duration. But yeah, that should make it work. Obviously, we have to change the parameter scan here because we want to collect it from the model perspective, not the individual perspective. And I don't think we have used it anywhere else. So in theory, if we reload our model, and we can reload it because we're not changing the agent but the model, it should now not have a problem. But it will now generate 6,820,000 rows of data, because we're storing the data for each individual agent. And you can tell it's kind of fast, so it's not really a problem to run and keep track of these data sets. So running these 1000 simulations for 30 steps takes about, if we run the add time command, where is the timing information here? It took about 3.5 seconds on this modern computer. So this is a way of how you can not just interactively visualize the data, but you can also scan your data, the parameters of your model, and systematically test the effect of individual parameters by then using this data frame and putting it into a statistical analysis software such as SPSS, R, or Yamovi, or whatever is your best statistical tool. You can of course do it using Julia if you're using the statistics package and the data frames package, but this is beyond the scope of this video, and I hope this video is already helpful for you. In the next video, we will see how we can extend our model by adding an additional layer. Actually, we promised that at the end of the last video, but to see the impact of the spread of awareness, that is something we will have a look at in the next video.